Hello students, how are you all? So I hope you all are doing well in your studies. So let's start with this particular session. I have come with a new topic. In the previous lecture, we have discussed the effect of placing a conductor under the influence of uniform electric field. So the important point was the electric field inside a conductor is zero. Right? That's the key point. This very fact would be used in today's article. Now look students, we are already aware of capacitor, the principle of capacitor, right? The types of capacitors, we have derived expression for parallel plate capacitor, for spherical capacitor, for cylindrical capacitor. The capacitance for different capacitors is different. It does depend upon the dimensions of the capacitor as well as the medium in which it is placed, right? So, in this article, what we are going to do is, we are going to study the effect on the capacitance of a parallel plate capacitor when a conducting slab is placed in the space between its plates. Right? So, this is our article. This is a parallel plate capacitor, right? Its principle we are all aware of. When an earth connected uncharged conductor is placed near a charged conductor, then the potential of this arrangement decreases drastically and accordingly its capacitance increases tremendously. So it is on this principle that all the capacitor works, right? This is a parallel plate capacitor and it is the case of air or vacuum. And suppose the applied field is E naught. Let us consider its capacitance is C naught, which will be obviously equal to Q by V naught. V naught is the potential difference. Naught means in the original case, when we are dealing with the case of air or vacuum. And let D be the separation between them. And area of each plate is A. Right? This article we have already done. But again I am doing it so as to compare the two cases. Now this is a normal parallel plate capacitor and the space between the plates is filled with air or vacuum. A is the cross-section area of each of the plates, right? Surface charge density is sigma, they are equal and opposite. The applied field, which is directed from positive plate to negative plate, that's E naught. The capacitance of this parallel plate capacitor is C naught. V naught is the potential difference across these two plates. This is case 1, the original case, right? So what we are going to do is, when a conducting slab, this is a conducting slab. This is a conducting slab. When this conducting slab is introduced in this space between the plates of the capacitor, then we are supposed to find out the expression for the capacitance and then compare what will happen. Will the capacitance in that case remain same? Will it increase? Will it decrease? That is what we are supposed to do in this particular article, right? So let's discuss this one. Let's start with the capacitance of a parallel plate capacitor. Although we have done previously in the previous session, still once again let's do it. Now look, this is the basic formula we are all aware. Capacitance is given by Q by V. Potential difference, it's given by the uniform electric field, which is considered to be E naught, multiplied by the distance between the plates, the distance up to which this electric field is effective. Now this formula has come from the concept of electric field as negative potential gradient. So remember, in case electric field is uniform, then the potential difference across the plates is given by the strength of the electric field multiplied by the distance between the two plates. Put this as equation 2. Also, we are aware the electric field in the space between the plates of the capacitor is given by sigma by epsilon. In this region, electric field is 0. In this region, electric field is 0. And in the central region, in the space between the plates of the capacitor, electric field is given by sigma by epsilon. Sigma is surface charge density, right? So, it will be given by Q by A epsilon naught. Sigma is surface charge density. And here we are considering the plates to be of negligible thickness, right? So, substitute this value over here. So what do you get? V naught, it will be equal to QD divided by epsilon A. From 1 and 4, substitute this value of V naught over here, what do you get? C naught, it will be equal to epsilon A by B. This will be from first and fourth. Put this as equation A. So this we were already aware of. So you can notice capacitance does depend upon the dimensions of the capacitor as well as it depends upon the medium in the space between the plates, right? So this is the original case. The capacitance of a parallel plate capacitor, in case the space between them is filled with air or it is vacuum, it's given by C naught equals to epsilon A by B. Now the main article begins. Now we need to find out the capacitance of the same parallel plate capacitor on the introduction of a conducting slab, say of thickness T. This is the distance between the plates, the same capacitor. So T is less than T. So again I repeat, our intention is, our objective is to determine the expression for the capacitance of a parallel plate capacitor where a conducting slab of thickness T less than the separation between the plates is introduced between them. Right? So as was discussed in the previous section, when a conductor is placed, then the field lines will get modified. Also, the net electric field inside the conductor is zero. That's the most important point. So net electric field inside the conductor, it will be zero. Net electric field inside the conductor will be zero. So electric field will be only in this region. And as you are aware, electric field enters or leaves the surface of the conductor at right angle. So it will be like this. It will enter normally. It will leave the surface of the conductor also normally. So this is the applied field, E naught. So this is how the diagram will get modified. So the electric field E naught exists only in this region, this and this. It do not exist in the region of thickness T. So electric field E naught only exists in the region D minus T. This is T and the entire region is D. So this region will be D minus T, isn't it? So mark my words. On placing the conductor or conducting slab in the space between the plates of the capacitor, the net electric field inside the conducting slab becomes zero. So the electric field E naught is effective only for a distance D minus T. For the thickness T, the electric field is zero. Right? So, in this case also, the capacitance would be Q by V, charge plus Q, over here minus Q, and V is the potential difference, which obviously would get changed. Right? This is 1 dash, suppose. Let's find potential difference. Potential difference across the plates of the capacitor would be E naught. I have told you, in case electric field is uniform, so it's given by strength of the electric field multiplied by the distance up to which it is effective. Now, in this entire region, electric field E naught is uniform, right? Over here it is 0. So, E naught electric field is effective for distance D minus T. Students, just consider the statement. Here it's E naught multiplied by D. Here the electric field was present throughout the region of thickness D, right? But here electric field E naught is present only in this distance, that is D minus T. So this is the important step. So substitute the value over here. So V will be equal to E naught, we are aware. E naught from 3 we get Q over A epsilon D minus T from 3. You can substitute this value of E naught over here and we will get this. So let us consider this to be 2 dash. So substitute this value of V in equation 1 dash. What do we get? From 1 dash and 2 dash we get C is equal to Q get cancelled. We will be left with epsilon A divided by D minus T. Check it. So, on placing a conducting slab in the space between the plates of the capacitor, the capacitance of the capacitor is obtained to be epsilon A divided by D minus T. Put this as equation B. Now what to do is, let us compare A and B. let us compare A and B. Let's see. From A and B, numerator both are same. Denominator over here it's D and over here D minus D. So denominator in this case is less than that in case A. So from A and B, we can safely conclude that C is greater than C naught. So students, what's the conclusion then? We conclude that when a conducting slab is introduced in the space between the plates of the capacitor, then the net capacitance tends to increase. On increasing a conducting slab, on introducing a conducting slab, the net capacitance of the capacitor tends to increase, right? So this is the mathematical verification. We will discuss a special case as well. Suppose, let us consider this special case. When T equals to D, let us interpret it theoretically. When T equals to D means when the entire space between the plates of the capacitor is filled with the conducting slab. So, in such a situation, what will happen is C in that case will be given by epsilon A divided by D minus T. It will be D minus T, so it will be infinite. Right? It will be infinite. So in this case, the capacitance of the capacitor will become infinite. Capacitance becoming infinite, what does it mean is that whatever charge is given to it, it will keep on accepting that charge. Whatever charge is given to it, it will not reject it. It will keep on accepting that charge. So in that sense, its capacitance will become infinite. But is it possible? Can a system have infinite capacitance? What is the physical significance of this, or how will you theoretically interpret it? So let me make it clear. This is the case. This is D. Now, this is earthed obviously, right? This is positive and this one is having negative charge. Now what to do is, a conducting slab of thickness T equal to the space between the two plates is introduced. So the entire space will be filled with the conducting slab like this. The entire space will be filled with the conducting slab. This will become a conducting slab. This will become a conducting slab, right? So it is a case of a simple earth connected conductor. It is equivalent to a case of earth connected conductor. So now what happens is, whatever additional charge is given to it, it will keep on accepting it. But actually the excess charge simply flows to the earth. Understood now? In that sense, it will keep on accepting whatever charge is given to it. The point to be noted over here is the excess charge will simply flow to the earth because it is earthed. So again, let me repeat this thing. When a conducting slab is having thickness equal to the distance between the plates of the capacitor, and such a conducting slab is introduced in the space between its plates, then the capacitor will simply behave, or it will rather act as an earth connected conductor. Earth connected conductor. Now when a conductor is connected to earth, earthing is there, so whatever additional charge is given to it, whatever charge is given to it, it will simply flow to the earth. So in that sense, it will never reject the charge coming to it. It will keep on accepting the charge, howsoever the charge may be given. But the point is, all the charge tends to flow to the earth. So in that sense, the capacitance of the capacitor becomes infinite. I hope you have understood the concept. So students, formulas to be noted down. In case of aero vacuum, the capacitance of a parallel plate capacitor is epsilon naught A by D. This is the formula for the capacitance of a capacitor in case of aero vacuum. In case of a conducting slab of thickness T less than D is introduced, then the formula becomes epsilon A divided by D minus T. So comparing these two, we can safely conclude that C is greater than C naught, which further elaborates the fact that on the introduction of a conducting slab, the net capacitance of the capacitor increases. Right? The net capacitance of the capacitor increases. Right? And this is the special case. In case the entire space is filled with the conducting slab, then the capacitor will simply behave as an earth connected conductor. So in that case, whatever charge is given to it, it will keep on accepting it. Simply the charge will flow to the earth. In that sense, the capacitance of this earth connected conductor will become infinite. And that is what we have mathematically justified over here. I hope this article is clear. This is very, very important from board exam point of view, right? So, let's discuss a simple numerical based on this.